Hi everyone and welcome to beyonds.org. Um, Today what we're going to deal with is basically going to be a set of problems, or actually one problem in this particular case, which has already appeared in one of your earlier question papers. Now this is from chapter 1, the first part of your chapter that deals with that we've already covered under part 1 class. And the that particular, to give you a quick overview, that particular chapter or that particular class worked with Euclid's lemma, fundamental theorem of arithmetic, long division. You had HCF and LCM and prime factorization. So this particular, we have a series of few questions, but the questions that I'm dealing with dealing with in this particular one session is something that's already appeared in one of your previous CBSE papers. So I thought it would be a good idea to go over it. So the problem that we are going to deal with today is, this is the problem. Show that one and only one out of n plus 1 and n plus 2 is divisible by 3 when n is any positive integer. Now what we've been asked to prove over here is, consider any number a, which is of the form 3q plus r. Okay, we know that there could be any positive integer. We know n is a positive integer, so that's what we've taken over here. A is a positive integer, and there could be a remainder, so r could be a remainder such that 0 is less than or equal to r is less than 3. So basically, which also implies r is equal to 0 or 1 or 2. So basically, there is a number such as a is equal to 3q or 3q plus 1 or 3q plus 2. Now we have to show that for any such number, that only one out of n plus 1 and n plus 2 is divisible by 3. Now consider a is equal to 3q. A is equal to 3q. n plus 1, n plus 2. This becomes 3q, 3q plus 1, 3q plus 2. Okay, is 3q divisible by 1 n? Yes. 3q by plus 1 is it divisible by 3? No. 3q plus 2? No. Similarly, let's take a is equal to 3q plus 1. So n plus 1, n plus 2. So this has basically become your 3q plus 1, 3q plus 2, and 3q plus 3. Is this divisible by 3? There's always a remainder, so no, this yes. Similarly, let's take the final one. A is equal to 3q plus 2, and then again you have n plus 1, n plus 2. So this basically becomes 3q plus 2, 3q plus 3, and 3q plus 4. Is this divisible by 3? No. Is this divisible by 3? Yes. Is this divisible by 3? No. So at any point of time, if you take any equation of the form a is equal to 3q plus r, and that we are taking, basically, if you see in this assumption, one question you might have is, why are we considering 3q? First of all, we have to make sure that we have to consider 3 numbers, because every third number will be divisible by 3. So you've got to consider 3 numbers. The way you are going to consider 3 numbers is only if you have something in multiples of 3. That is, you have first number as 3q, next number as 3q plus 1, third number as 3q plus 2. So when you have multiples of 3, you will consider that as that becomes a number for you. So you have 3q, so that's why we've taken it as 3q over here, and of course the remainder, this is basically coming from your Euclid's lemma. Right? So this is the solution to this problem. If you notice over here, just in case you're not able to understand my handwriting, that is what I've explained over here as well. So basically I've taken n is equal to 3q plus r, and since r0 is less than or equal to r is less than 3, we know that n has to be of the form n is equal to, this should be actually q plus 1 or q plus 2. So it's of some of one of these forms, and therefore n is equal to 3q plus 0 or 3q plus 1 or 3q plus 2, and hence we've solved it over here. In every case, we've taken that if n plus 1, what would be the value, n plus 2, what would be the value, and what is divisible by 3. So that's what we've done, and then hence we've proved that in each case, either n plus 1 or n plus 2 is divisible by 3, not all 3 at the same time. Now visit us on Vyans.org for more such questions. We have a simple test for you as well. So visit us on Vyans.org for working out these questions, as well as seeing other videos related to this chapter as well as other chapters on your maths. Thank you and have a good day.